Hello world and welcome. Today we are going to see how neural nets we are going to use in fraud detection. My name is Harris and let's get started. So for more content, so tutorial, hit the subscribe button or leave a like or comment there. Thanks a lot. Today we are going to use neural nets for fraud detection. Therefore, to just sum it up, we are basically having input layer, output layer, two hidden layers. You can see here the neurons in the hidden layers, which are connected to each other. You have as well the bias, the weights, and the activation function, which are going to produce the output. Today, our data, as you will see afterwards, is really imbalanced. Therefore, we're going to use oversampling to take the majority class and oversample the data that we have kind of some balanced data. The fraud dataset, which we're going to use today, has a time column where you can basically see what is the second between the transaction itself. We have a V1 to V20H, which are just representing some PCA, so principal component analysis dimension reductions, because it contains sensitive data like age, sometimes name, etc. Also the amount of a transaction is also important, and then we have the target, so the class, which is either 1 or 0, 1 for fraudulent. So let's check the code. Therefore, we are going to take here the packages, like we are going to use smooth, which is oversampling technique, and then also other packages like keras, models, and layers to produce the model itself. Then afterwards, we're going to import the data, the credit card data, and then we have the X and Y. So here you can see the X data and the dimensions, and then we're going to split the train and test data set. And then here we see in the histogram that you have imbalance. The blue line that you can see here is the not fraudulent data, so the 0, and in this small line you can only see the fraudulent data, so it's pretty imbalanced. That's why we are going to use the smooth technique, so the synthetic minority oversampling technique, to more balance the data. You can also choose the sampling strategy. I choose 80%. That is not like really balanced, but up to 80%. So now it looks more balanced, so we can use the data itself. Then we are going to create a neural net with a sequential layer here, and then a dense layer, which has 30 inputs, and activation is here for sigmoid because it's a classification. And we have dense layer, which represent the output layer here. We have the optimizer, which we are going to choose the atom itself. So when we start the training, we can see that the accuracy is around about, let's say, 93%, which is pretty good. Here you can see the summary of the dense or the layer itself with more than 2000 parameters. If you evaluate it, here you can see even a higher accuracy of 99%, because we test the data with imbalanced data again. That's why we have this kind of pretty good accuracy, so it's kind of oversampling already. But if you would test it with balanced data, then you would have an accuracy of around about 93%. So here I also print out weights and the bias, which are in a pretty good range. So if something is, you can see here the bias, if it would be like a higher value, then you would know that the model itself is not so good. So thanks for watching, and please hit the subscribe button to see more content. And thanks a lot, and see you soon.